Let's talk about differential line growth and how we can use L systems to further modify the initial shape that we get to create some really unique animations. So as always, this project file will be available on Patreon, so you can grab it on there. This is probably going to take a few videos in order to get everything together, because I have to not only show how the differential line growth works, but also how L systems work because they're a little bit complex, and then how to combine them together. Because while you can just toss in a L system into a differential line growth setup and it will work, in order to get some more unique animations, you need to do some extra steps. So let's start off by just building the differential line growth setup. So let's drop down a SOP create because we are in Solaris here. And I'm just going to drop down a circle. We'll use that as our base shape to start off just for the example. So we'll set this to ZX plane. I'll crank up the divisions and set this to an open arc. And then because we're in Solaris, sometimes we will get this preview kind of shape. It's going to try to show any lines that we have as like a strip. So we want to just make sure that that doesn't happen. So I'm going to drop down an attribute wrangle. If you're in the regular geo context, you don't have to do this, but drop down an attribute wrangle, and I'm going to create a float attribute called width, and we'll just set that equal to 0 just to get rid of any viewport visualization that we would have. Now we can drop down a SOP solver and we can dive inside here. So because our object is going to be changing shape, we only have this number of points. So we want to maintain, a similar spacing between each point, and we want the shape to increase in resolution as it changes. So the way that we do that is with a resample node. So we can drop that down, and we'll leave it on the default settings here for now. And I'm going to drop down a fuse as well. That way, if we have any points that are too close to each other initially, or an open arc that is not meeting at the ends, and we want it to meet, that it is going to have those points be fused together. So we want to push each point away from the other points, and we can do that with a point relax node. And it's going to take a value in here called p-scale. So we need to give it that value. So let's drop down an attribute wrangle again. And let's do f at p-scale is equal to, and then we need this value to be greater than this length value that we have in our resample. So just pay attention to what you have set here. And we can set this to like 0.12 to start off here. And that's going to give us some growth. Now I'm also going to just smooth this mesh out after we run this relax, just to give us a little bit more of a smoother shape. So let's jump back here and reset the simulation. And if I press play now, it's going to happen very, very quickly. See what's going on here. We have this shape that grows on, and you can see that it's trying to push the points away from each other. And as it does that, it creates more points, and that's where that resample comes in. So this happens super, super quickly. If you want to slow this down, let's go ahead and actually just make a second one of these. And we can dive inside, and we have this p-scale value in here. So we have it set to 0.12 right now. If I set this to like 0.0 or 0.1, like 0.001, it's going to slow that down quite a bit. So I can drop down a switch, and we can wire those in there, and we can see what happens with this. So if I press play now, if I look at the second input here, you can see that we're moving a little bit slower in that second input, where the p-scale is just a little bit larger than what we have set in our resample node. So that's a good way to control that, and that's good to understand for later. So if your animation's happening too quickly, you can kind of slow that down and work with it to meet your needs. So let's just delete those for now. Now this object is very uniform. We don't want it to be so uniform, so we need to kind of break up that shape. The way that we do that is by randomizing the p-scale on each point. So I'm going to go ahead and just delete this attribute wrangle. And let's drop down a point VOP. And we're going to use a noise in order to do this. We can jump back to frame 1 there. So let's drop down a unified noise. We can wire in our point position. And then let's drop down a bind export. Because as I said, we need to make sure that this is set to P scale. Now, the values that come out of this noise are going to be, between like 0 and 1, for example, depending on the noise that you're using. And as we saw with 0.12, the noise moves pretty quick. So we don't want it to be all the way up at a value of 1 because it would be extremely fast and you wouldn't really get much animation. It would happen just like in the blink of an eye. So we need to remap these values. So let's drop down a ramp parameter and wire in our noise. Let's make sure this is a spline ramp, and let's wire that ramp into our P scale. And we can jump back up to our point VOP here. And let's make sure that this second value has a value higher than the value that we set in the resample. So I'm going to make sure that this is 0.12 to align with what we had before, to give us a similar speed in the growth. So let's jump out of here and reset the simulation. I can press play. And you can see that this gives us a more non-uniform shape. And you can play around with the different noise types to get some different looks. Let's take a look at what that may look like. Actually, let's create a copy of that. And let's jump in here. Let's set this to maybe like sparse convolution. And we can reset our simulation there. Let's drop down our switch node again. Wire these in. And if I press play, we get this value or this kind of a shape growing with our first solver. And for our second one, we get a completely different shape. So you can play around with the different settings of each noise and see which one, works best for the situation that you're looking for, the shape that you're trying to get. You can get all sorts of different shapes with that. But I want to eventually get us to a point where we are using a different shape for our input here that's going to give us a much more unique look to our differential line growth. So the way that we're going to do that, which will be in the next video, is going to be by using L systems. So they are a little bit more complex. There's some things that you need to understand about how they work in order to get you some unique shapes to start out with that we can then plug into our setup that we have here and generate some interesting shapes to start off with. Now, we'll have to add some extra stuff in there in order to really have a more unique animation, because otherwise it's going to affect every point all at once. And I want to point that out, that you see with these animations that we're having every point being moved all at once from the start. And I want to kind of have that animate along. So we'll go over how to do all that in the coming videos. But anyways, thank you guys for watching. Hopefully you learned something with this little differential line growth setup, and we'll continue to build on this in the next few videos. Anyways, thank you guys for watching and have a good day.